An economist is evaluating the relation between economic growth and currency appreciation. He uses historical data to determine the probability that the economy grows 63%, economy shrinks 24%, and economy stays flat 13%. So this 63, 24, and 13 totals 100%. So these are the probability of the events. Those are the probabilities of the events. Now, the economist estimates that given the new information regarding the currency, the probabilities that the economy shrinks or stays flat are as follows. So the new information is given the new information that the currency appreciated. So the new information is the currency appreciated. So now, if you memorize the formula in the CFA Institute curriculum, you will be given probability of event given new information is equal to the probability of that event and information occurring, both are occurring, divided by your probability space. So it means if the event happened, what's the probability of the event given that information already happened? So given the information already happened, that will be your denominator or your probability space, right? Or probability universal space. So now, can we figure out what are these variables? Can we figure it out? Let's say probability of event. Do we know it? So in this case, we were asked the probability that the economy shrinks. Probability that the economy shrinks. So I will write here probability that the economy shrinks given the new information that currency appreciated. Clear? So this is how I write it. The same as this is the formula in the book. We'll just write it in a way that is applicable to the practice question. So probability of ES and CA, currency appreciates, both occurring together, divided by your probability space. Now, can we get this probability of currency appreciation? It is not given here. It's not given in this practice question. So what we should do is we should calculate it. So we have to calculate. In order to calculate that, we have to apply the total probability rule. So the total probability rule will give you the the unconditional probability that event will happen. So let me give you the formula for the total probability rule here. I'm no expert, but I'm a student like you. I'm a candidate, so I'm learning as I am recording this video. I'm learning more and more. So total probability rule. The formula in the book is this: probability of the currency appreciating. Actually, it's not the probability of the information or probability of the event is equal to probability, in this case, probability of the information. So you'll have to get the probability of currency appreciating given event number 1. So in this case, in our practice question, the economy will grow multiplied by probability of the event that the economy will grow. So it's total probability. So we have to add, right? Multiplied by probability of currency appreciating given the economy shrinks, multiplied by probability that the economy shrinks. And then the last one will be, because we have 3 events here, so we're saying what is the unconditional probability of currency appreciating given the events. So it has to be dependent events and mutually exhaustive. So it means all of this should not happen at the same time. One should, if this happens, this cannot happen. And the total of the 3 events should be 100%. So the last one will be probability of the currency appreciating again given the economy stays flat. F. Multiplied by the probability of the event of the economy staying flat. So applying it here, hold on, probability. So for me, if I want to say you're just starting and you don't want to memorize the formula, you have to work on decision trees. Decision trees is very useful. You'll be using it in levels. In level 2 definitely, but in level 3 I'm not sure. But in level 2 you'll use it definitely. So we'll plot the probability of the event. These are the events. Hold on, these are the events over here. So those events, economy grows, shrinks, and stays flat. Total of them 100%. It's just plot 63, 24, and 18%. And then for each event, you have 2 scenarios. It's either the currency will appreciate, currency appreciating, or the currency will not appreciate. So I cannot say currency depreciated. It can be currency depreciated or currency remain the same. This CA complement. CA currency appreciating, currency not appreciating, or CA complement. So we are given, how do you write it? How do you write this? So how you read it is probability, this one, EG, this is probability of economic growth. And this over here, you can write it as probability of currency appreciating given that this event occurred. So EG. So let's go back here. So probability of currency appreciating given EG is how much? As per this practice question, it is 0.74. Currency appreciating given EG. So what we have here is 0.74. And then you multiply it with the probability of the event. So you'll notice that this over here is 74% times 63% or 46.62. That's how you, this is how you visualize the total probability rule. So next step, probability of currency appreciating given economy will shrink times probability of economy that will shrink. So let me erase this. Let me erase this one. Okay, now we are in this mode. We are in this mode here. Here. Over here. Right? So what is the probability of currency appreciating multiplied by probability of the currency appreciating given probability of the economy shrinking? So that is 0.11, which is this over here, multiplied by probability of the event shrinking. So 0.11 times 0.24 is equal to 2.64. So we managed to complete the second. Then we'll go to the last. Let me just clear it. The last one. Now you're following. Next, probability of the currency appreciating given the economy stays flat multiplied by probability of the economy staying flat. So this is this one, currency appreciating, economy flat or unchanged. So this is this mode here, module or node, sorry. So probability, this 15% here is the probability. I'm writing again and again, so you build muscle memory here. Currency appreciating given economy stays flat, right, which is 15%. So I write here 15%. Clear? Multiplied by the probability of the event, which is the economy stays flat. So it will be 15% times 13% equals 1.95%. So we completed. Now we know if we add these green ones, if we add these green colors, you will have here the probability of currency appreciation or appreciating 51.21%. So we can plug this figure over here. So this is 51.21%. Now observe. Now, what is the probability of ES? Economy. Let me select a good color here. Not this one. 1 minute, please. Right. Probability of ES. Where's ES? This is ES. I should have erased this. ES multiplied by CA. Right? So probability of ES times probability of CA will be how much? 2.64, right? This one. Clear? So we'll plug it here. It is the joint probability that both events will happen. You see here probability of CA and ES. This one. Because how I write it is this. Probability of ES. Probability of CA and then ES. 1 minute, I'm figuring it out. Because I know it's 2.64. I know the answer. But 2.64 here divided by 51.21, which is 5.15. 5.155%, which will give you choice A. But in the next videos, we'll get these questions for all. Now this is only for one. %2.64% probability of ES. Because you will notice here, this one will be cancelled. See how I arrive at this one. CA and ES. CA and ES, which is this. How I arrive at PCA, joint probability times probability of ES. The way I arrive it is you cross multiply these two. It will be probability of ES given CA times probability of CA is equal to probability of ES given multiplied by probability of CA. You see this? ES, CA, ES and CA, where are you? Which is this one, probability of ES times probability of CA. Yeah, that's what it means. You knowing this formula. And then what else? You can do it for everything. So let's try the first one. Let's say the probability not the first one. Let's try this. Probability of A given B is equal to both will have both events has to occur. You know that probability of A given B already occurred. So if B already occurred, so they have to happen at the same time, right? And then given probability of B. So this will happen. This happened provided B already occurred. So this will be your probability space. So you can just cancel this actually. Or you can rewrite it like this. Probability, you cross multiply. So this is the denominator. So what I will do is multiply it by basic algebra, probability of B. Then you multiply it by 1 over probability of B. So, oh no, sorry. Yeah, the goal is to cancel it, right? So probability of B, the numerator, divided by 1. So you'll cancel this times probability of B here over 1. So you'll have probability of B multiplied by probability of A given B equals probability of A times probability of B, right? Or you can write it in another way, probability of A and B happening at the same time. Just clean this. See, this is what will happen here in this part of the this is the like the product and product, just rearranging it using algebra. It's really difficult to articulate it. Sometimes it's better to articulate something using formulas, because it's really, explaining math in simple English or in any languages, it will not work. It has to be articulated in a mathematical way, and just by looking at this you will not be able to get it. I mean, it requires practice, right? So I'll be doing there will be a next video on this one. So we'll answer some more base formula based on this given problem. So for example, as a preview, I will have here second question, probably probability of the economy is economy shrinks given CAC. Given currency did not appreciate. So in this case you will write it like this. So you have to get used to writing the formulas. ES, this has to occur at both of them. So probability of CA complement, and remember this will be your probability space. Keep writing it, keep practicing, and to build muscle memory. So in case, because CFA is, it's not that hard, but it's a mile long and 2 inches deep or 1 inch deep. Just the volume of the number of formulas, the number of subjects to cover. You have, I think, 57 or 58 readings. So let's solve this number 2. Probability, you're looking for this. This is base because we have the event and we're giving you information that the currency will not appreciate. Given the economy shrinks. So what's the probability of ES times CA's complement? So we'll be looking at this ES here given CA complement. So 89% times 14%. Is it 89? Yeah, it's 89. So 89% times 24% is 21.36% in the numerator. And then probability of the complement. Currency appreciation. Currency will not appreciate, or CEC complement. CA complement, not CEC complement. So you have to apply the total probability rule again for these orange ones. You have to apply the total probability rule and do like this. So it's probability of, let's say, CA complement here, given that the economy will grow, multiplied by the economy will grow, blah blah blah. So this is the one, 48.79. I'll just plug the figure here. What's the base formula here? It's this one, 21.86 divided by 48.79. If you use this, it will be a lot easier. But you have to do it fast. Like in 90 seconds. So good luck. 43.79%. Then you can go on and on and on. So let's say question number 3, let's say EF. Let's try this. Probability that the event that the economy stays flat given currency has appreciated. So we'll write it like this again. Probability of EF, economy stays flat. Both of them should happen, right? Currency appreciates. Remember, this is your probability space. So probability of currency appreciating. So here you have to get the total probability. Use the total probability rule to get the probability of the information that currency appreciates. So you have here, not this, which is 51.21%. So let me plug it here, 51.21%. Probability of EF, CA. Where's EF here? EF and CA, which is this. 13% times 15% is 1.95%. So 1.95 divided by 51.21, 3.807 percentage. Right. So which is 1.95 divided by 81.21. So if you have this, if you can quickly build this, you don't need to memorize this, because even if you memorize this formula, you have to get the probability of information, and you have to know the total probability rule, which is this. And memorizing it, it's not advisable. You have to, you can memorize it with understanding if you know how to draw a decision tree, which is, I think, it's really helpful. And then this total probability rule will be automatic if you master this. And then it's game over.